Okay, so this is the displacement versus the weight graph. So instead of it being the total length, like most of you did, and your y-intercept was the length of your unstretched spring. Now we get an equation that looks like delta x is equal to a slope value. I'm going to use the word slope because M stands for what in physics? Mass. And it gets really stinking confusing if you use that letter for both slope and mass, especially when you have slopes and masses in the same lines. Okay? And then this would be your gravitational force. Okay? Now, let's draw a free body diagram of the mass that was hanging. So you had your little hanging mass. And what was interacting with our hanging mass? The Earth was interacting, causing a force of gravity. That's right. And that was pointing towards the Earth. What else was interacting with our mass that was hanging? The spring. And that was creating a force holding it up. So a spring force. Were they balanced? Yeah, they sure were. So they're in equilibrium. So when I sum up the forces, my spring force is positive, my weight force is negative, and they would equal 0. Now, that means, so when I sum up these forces, I'm creating a force equation. Before, when we were doing kinematics, we had 3 equations to use all the time. Now with forces, you're going to draw a free body diagram and then sum the forces. That's the process. Okay, so let's see. That means that the spring force is equal to the weight. So I can look at my equation. My equation for the line was delta x is equal to the slope value times the gravitational force. Well, holy cow, let's see. The gravitational force is the spring force. So let's make a substitution. Delta x is equal to slope times the spring force. Okay? Now, in physics, we want an equation that says the spring force is equal to something. So what do I need to do to make an equation that says the spring force is equal to delta x over slope? That's exactly right. And that's the same thing as saying like 1 over slope times delta x. Right? Okay, so here it goes. If we create a position force graph, so you created a position force, and it was a gravitational force, which we just proved is the spring force, and we got a line like this, and we got a slope of that line. Okay? Now, this, rearranging it for the spring force, makes us have a graph of force versus displacement. Basically, we switch the vertical and horizontal components, or vertical and horizontal variables. So put x there. So now we get a slope that would look like that. And in terms of the slope of the first graph, what's the slope of the second graph? It would be 1 over the original slope. That's right. And this is how most of the time you will see the spring force drawn or described. And this value, the slope of this line right here, is called the spring constant, which is a K. So this is the spring force constant.